Okay, so this is part 213. This is just words, data, that type of thing. Okay, so it's line 18V, Lewis number, flames, kinetic energy transport, 5G Wow Seti. So there's the alien radio signal. So I'm going to Google the Lewis number effect. That came up earlier and I wanted to find out what it meant. So the effect of Lewis number on radiative extension and flamelet came up, a PDF file from T. Shamin in 2002. Lewis number with different transient effects such as fluctuating reactant, effect of non-unity Lewis numbers and their interaction with chemistry. Another one came up, the effect of Lewis number variation on combustion valves from Gubernov. It is shown that the Lewis number for fuel has a significant effect on the properties and stability of premixed flames, whereas the Lewis number for the radicals. And the next thing was the physics of fluids. This book came up, effects of Lewis number on turbulent kinetic energy transport in premixed flames, from Neojan Kaparti and Mohit Karita. Pretty new, 2011. Effects of Lewis number on turbulent kinetic energy transport in premixed flames. That comes up from these guys here. The effects of global Lewis number on the statistical behavior of turbulent kinetic energy transport in turbulent premixed flames are analyzed using three-dimensional direct numerical simulation DNS data for freely propagating statistically planar flames with Lewis number ranging from 0.34 to 12. For flames with Lewis numbers significantly smaller than unity, it is observed that the turbulent kinetic energy is significantly augmented within the flame brush due to the flame-generated turbulence. In these flames, it is demonstrated that the effects of the mean pressure gradient and pressure dilation are sufficient to overcome the effects of viscous dissipation. By contrast, for flames with Lewis number close to unity, it is found that the turbulent kinetic energy decays monotonically through the flame brush. In these flames, the effects of the mean pressure gradient and pressure dilation terms are relatively much weaker than those of viscous dissipation. The modeling of the various unclosed terms of the turbulent kinetic energy transport equation has been analyzed in detail. The predictions of existing models are compared with corresponding quantities extracted from DNS data. Based on this a priori DNS assessment, either appropriate models are identified or new models are proposed where necessary. It is shown that the turbulent flux of turbulent kinetic energy exhibits counter-gradient transport for the low Lewis number flames, where the turbulent scalar flux is also counter-gradient in nature. However, for flames with Lewis number close to unity, the turbulent flux of turbulent kinetic energy exhibits predominantly gradient-type transport. So a lot of it has to do with transport, so I believe this has something to do with the actual UFO engine, okay? A new model has been proposed for the flux of turbulent kinetic energy in premixed flames and is found to capture the qualitative and quantitative behavior obtained from DNS data for all different Lewis numbers considered. Okay, so there's all the results that they came with. Keywords: flames, flow simulation, numerical analysis, turbulent diffusion. It's from the American Institute of Physics. So that's come up. So I believe that has something to do with the engine, which is why I did the 5G, okay? So we'll go on to our next video then.